261 upvotes. This paper just hit the top of Hugging Face, and the research community is paying attention. Today we're breaking down a paper that claims something bold. AI can learn scientific taste. Let's dive in. What makes a great scientist great? It's not just technical skill. It's judgment, foresight, knowing which ideas are worth pursuing and which ones are dead ends. The authors call this scientific taste, the capacity to judge and propose research ideas with high potential impact. And they ask a fascinating question. Can AI learn this? Can we train a model to tell the difference between a paper that will get 1,000 citations and one that will get 10? Here's the clever part. You know RLHF, reinforcement learning from human feedback, the technique that made chatbots actually useful. Well, these researchers propose RLCF, reinforcement learning from community feedback. Instead of expensive human annotations, they use citations as the training signal. Citations are basically the scientific community voting on which ideas matter. They built a dataset called SciJudgeBench with 700,000 matched paper pairs, same field, same time period, one highly cited, one not. That's your preference data. That's your community feedback. First, they train Scientific Judge, a model that looks at two papers and predicts which one will have higher impact. It's trained with GRPO, where the reward is simply, did you pick the right paper? The results are wild. Their 30 billion parameter judge beats GPT-5.2 and Gemini 3 Pro at predicting which papers will be more impactful. And it scales beautifully: more data, better performance. Bigger model, better performance. Log linear scaling all the way up. But judging is only half the picture. A great scientist doesn't just evaluate, they create. So they build scientific thinker. Given a seed paper, thinker proposes follow-up research ideas. And here's the elegant part. They use the judge as the reward model. The thinker generates multiple ideas. The judge runs a round-robin tournament comparing them pairwise, and the win rate becomes the reward signal. It's reinforcement learning for scientific creativity, and the results show thinker produces higher impact ideas than all baselines. Let's look at the actual paper. You can see the results tables right here. Scientific Judge outperforms every proprietary model tested. And look at the generalization results. Trained on computer science papers, it transfers to math, physics, and other fields. Trained on citation data, it even aligns with peer review preferences from ICLR submissions. That's remarkable cross-domain transfer. Let me hit you with the key numbers. SciJudge 30B achieves 80.6% accuracy overall, beating GPT-5.2 and Gemini 3 Pro. On temporal generalization, predicting impact of papers from 2025, after the training period, gains of up to 55 points. On field generalization, trained only on CS, tested on math and physics, consistent improvements across the board. And on peer review alignment from ICLR, improvements of up to 72 points. The model doesn't just memorize citation patterns, it learns something deeper about what makes research impactful. Here's why this matters. We've been building AI scientists that can search literature and run experiments. But this paper tackles something more fundamental. Can AI develop taste? Can it learn what's worth pursuing? If the answer is yes, and this paper suggests it is, then we're not just building tools that execute. We're building systems that can guide research direction, identify promising frontiers, and maybe even propose the next breakthrough idea. The link to the paper is in the description. This is one you'll want to read. I'll see you in the next one.